Riverpod is the response to all the insufficiencies of other dependency injection and state management packages for Dart and Flutter apps. It's quick to get familiar with, maintainable, testable, and it's also much less error-prone than the other solutions out there. So let's take a look at the core principles of Riverpod. Hello, welcome to ResoCoder, where you're getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, we are going to focus on Riverpod, of course, but before we do that, let's take a brief look at the different ways of doing dependency injection / state management of sorts with other packages in the Flutter ecosystem. So there are multiple ways to provide dependencies around your Flutter app, and there are service locators such as Gedit. They are great, but they aren't directional, which means that you can access objects in whatever order you want, and you are not necessarily guaranteed that all of them are properly initialized, unless you're careful, of course. So the issue with Gedit, Kiwi, or other service locators out there is that you cannot be sure that what you access is actually properly initialized, and then you can have errors because of that. We're not going to focus on service locators such as Gedit at all in this tutorial. That's just something good that you know about. And then another solution, which is already fairly well established in the community, is the Provider package, which I'm sure that you have already heard about. And therefore, I assume that you already have some sort of a experience with the Provider package, because I'm going to be comparing Riverpod to Provider quite a bit. Since it's from the same author, it kind of makes sense, from Remy Rosselet. So I have already added the Provider package over to the pubspec YAML. And let's just briefly go through why this sort of original, quote unquote, provider is not perfect. This is going to be a brief, quick rundown, and then we are going to jump right into Riverpod once you understand the provider's drawbacks. And also be sure to check out the written tutorial from the link in the description, where you can find all of the code written in this video, links to all of the different libraries such as Provider, Riverpod. All the different examples I give over here are going to be linked in the written article. And overall, you can go through this lesson at your own pace. So we have this simple app structure. We have my app, and then we have my widget, which is inside of the scaffold. Currently, it displays only a container, but let's just imagine that you also have a usual class, my first class, which simply holds some sort of a value field, hello, all right? Then you also have my second class, which depends on the first class, right? So how would you construct this sort of a dependency tree of classes with the classic provider? Well, you would need to do something like this. Horrible, right? So let's just jump through it. What we are doing, you don't need to fully understand this if you have not seen this yet, although I suspect that you did, because Provider is kind of like the king of all of the packages out there. It's the most liked package, I think, on pub.dev anyway. But basically, what you have here is a top-level provider, which provides my first class, this one. And then you have a proxy provider. That's because you need to get the my first class instance into the constructor of my second class. And proxy providers can do just that. Inside of the update method or function, you get the first class instance from the provider above, and then you can pass it to my second class as you construct it. And this makes the my second class also available inside of the widget tree below. And then we have a builder just so that we can get the immediate proxy provider's provided class above. And over inside of the builder, we just access the my second class using the familiar provider of syntax And from the my second class, we get the my first class instance. And from that, we get a value. And if we open up the app, we should see a hello. Hopefully you can see it also on YouTube. It's very small, but we can see hello in the corner. So we know it works because the value of my first class is hello. This looks absolutely horrible. It's nested. And as if that wasn't enough, you are also using widgets to provide dependencies around your app. I'm not sure about you, but I am not very comfortable with mixing the UI code with providing dependencies. UI code should be reserved to the UI in an ideal world, and managing dependencies is surely not the thing which UI should be doing. At least we should not be mixing these two codes together. We should be able to just separate our providers into a separate file so that they can be properly and nicely organized in a readable way. And this is not readable at all. Then, if we delete these two classes because we don't need them anymore, we can demonstrate the second huge drawback of the classic provider. If you have something like this, just two nested providers, each of them provides a string, then what's going to happen is that this text, which gets a string from a provider, is always going to get only the string that is closer to the call site. There is just no way to get a string far away from this provider's builder, because a string that is close is just closer. That's how inherited widgets work. There is no way we can go around that. So therefore, if we now take a look at the running app, we see in the corner a string that is close, and that may not always be what you desire. Sometimes you may want to get a string far away, but there is just no way to do it with the classic provider. And of course, lastly, let's just try getting a type which is just not present inside of the app. So for example, integer, some sort of an integer, right? And then convert it to string because we want to display it inside of a text widget, or to string, not to signed, to string. What's going to happen is that we are going to get the all familiar error that we cannot find a provider int. That's because there is just no provider of an integer. But the problem is that we are able to even write this code. We fail only at runtime, but in an ideal world, we would like to fail at compile time so that this code would not even run and we would see an error inside of our VS Code or Android Studio. That's just much easier to debug than to debug something at runtime. So let's now take a look at the basics of Riverpod. Let's jump into pubspec YAML, and I'm gonna get rid of the provider. And let's put Flutter Riverpod dependency over here. Currently it's at version 0.12.1. Although it's not at the version 1 just yet, its API is fairly stable and you should not really expect any breaking changes down the line. There may be some name changes, but the principles are going to remain the same nevertheless. You can also check out the written tutorial from the link in the description where you are going to be able to get this dependency version yourself. There are also multiple packages for Riverpod. The Flutter Riverpod is just for pure Flutter. Then you have hooks Riverpod if you are using Flutter hooks. We are not going to use that package in this tutorial, but if you are interested in Flutter hooks and how they work, check out the tutorial from the card in the corner. And then you have also just a default Riverpod package like this, because Riverpod is able to work without Flutter completely. It's just not dependent on Flutter. So you can also use it from other pure Dart projects and also from unit tests, therefore. Riverpod also uses a class called a provider, but Riverpod's providers are a bit different than the original providers. They are not going to be put into a widget tree, but instead they are put into variables, global variables, and these variables can be put into any file you want. As long as you can access these variables, you're good to go. But for simplicity, we are going to put all of our code inside main.dart, but you absolutely don't have to do that. You can organize your Riverpod's providers however you want. So let's create our first very simple provider. We're gonna put it inside a final greeting provider. And it's going to be a provider from Riverpod. This accepts a create function, which passes us a ref parameter, which is of type provider reference, and we're going to get back to this parameter later on in this tutorial. It's mostly used to resolve dependencies in between providers, something like you could have seen in the proxy provider example with the original provider, but it's just much simpler to use this one than proxy provider in my opinion. And let's just provide some sort of a greeting, a string, hello, Riverpod. All right. Now you may be a bit confused about the global aspect of a provider because it's put inside a global variable. So is this just not something global? And you may have heard that globals are not good to use, and that's absolutely correct. But the thing is that a provider is not global. Only the provider definition is global. This is much like with some sort of a global function. So if we have a code looking like this, right? We have a global function right here, which returns a string. This function can be called from anywhere we want because it's global. So the function definition is global. However, once you call this function, the value that it returns can also be scoped locally to just this one class method, right? The function itself is global, but the value it returns is local in this case. The same idea applies to a provider. The provider definition is global, but in this case, the string it returns can also be scoped locally to, for example, a certain widget. And as soon as that widget is disposed, this value will also be disposed. Of course, this just doesn't apply to string providers. You can have all kinds of crazy providers like stream provider, FutureProvider, then you have ChangeNotifier provider, state notifier provider, all that good stuff. The scoping applies to them also. Now the question stands, where are the widgets? Because although it's great news that Riverpod's providers are Flutter independent, we probably still need to use the value provided by this greeting provider from inside of the widget tree because we are operating within Flutter after all, and everything is a widget, and somehow we just need to get this value over here into the widget tree. The Riverpod package comes with a single inherited widget that needs to be placed above the whole widget tree. And this widget is called provider scope, and you should just wrap the whole my app inside of the provider scope. This provider scope is responsible for holding something called provider container, which is in turn responsible for storing the state of individual providers. And again, although there is only one provider scope, the state of providers is not necessarily scoped to the whole app. Through some very good written code, the state of a provider is being managed and therefore created and disposed based on a widget from within which it's used. You'll see in just a bit. How do we then obtain this string from our greeting provider? so that we can get it, for example, into a text widget. There are actually multiple ways to do that. The first way is to change our stateless widget to be a consumer widget, which comes from Flutter Riverpod. Then this build function will need to take in another parameter. So that one is scoped reader, which is a function type def, and it's usually called watch because this scoped reader is going to watch any given provider, and it's going to also cause the widget to rebuild if the value from a provider changes. Since we are using just a simple provider providing a string, which is basically constant, there aren't going to be any changes. But if you have something like a ChangeNotifier provider and you call watch greeting provider, if this had any changes, each change would cause this widget to rebuild because you are watching the provider. Now let's just put this inside a final variable greeting, which is of course going to be of type string, because string is the type which the provider provides. And now we're just able to put this greeting string into our text. And if we open up this thing, we just cannot see absolutely anything happening. Why is that? Well, let's just hard restart the app so that all the things we have added over time can properly initialize with the Riverpod. And now we see hello Riverpod inside of the UI. Then the other way we can get the value from the provider over to our UI, and to also optimize widget rebuilds while we are doing that, is to not use a consumer widget, but instead a specific consumer widget, which is called a consumer. So we are now going to extend our own class with consumer widget. Instead, it's going to be a stateless widget as before. So it's not going to accept any scoped reader inside of the build method. And instead, we are just going to wrap the specific widget that we want to rebuild with a consumer. So there is this trick: wrap it with a stream builder, remove the stream, remove the stream builder, let's just call it consumer, and the builder takes in a context, a watch function, which we have already seen, it's of type scoped reader, and also child. All right. And now we can call watch greeting provider from this little optimized consumer widget. And why is this more optimized than what we had before? Well, previously, if any change occurred inside of the greeting provider, we would rebuild the whole material app. But now we are rebuilding only the text, which is truly affected by the value change. And still, we can see hello Riverpod from our running app. Now, how can we just read a provider one time without watching it? Because as you may know, sometimes it may be impossible to call watch because you are not directly inside of the build method. For example, you can be inside of a onPressed handler of a button, and from over there, it's invalid to, well, invoke widget rebuilds with watch. That's exactly when you can call context.read. So let's showcase something more believable now. We're going to create a ChangeNotifier provider. So let's just create a simple increment notifier. It's of type ChangeNotifier, it just has a single value initialized to 0, and an increment method which simply increments the value by 1. We could also write something like value plus plus, obviously, to make it even more simple. And then it calls notify listeners as is usual with change notifiers. Then we are going to create a increment provider. So it's also going to be final increment provider, but instead of just a simple provider, it's going to be a change notifier provider. It also takes in a provider reference, and it's going to return an instance of increment provider or increment notifier, right? As opposed to the default provider, change notifier provider will cause a widget to rebuild whenever it's watched and the provided value changes. Let's now actually delete the greeting provider since we don't need it anymore. And I'm just quickly going to paste here the code for the very standard counter app, which you have probably seen by now countless of times. And as always with tutorials here on ResoCoder, you can get this code from the link in the video description from the written tutorial. So basically, we have a simple scaffold and a widget which displays the value from our increment change notifier. We get this value, which is being incremented, by watching our increment provider. So this is the stuff that you have already seen in this tutorial, right? We are inside of a consumer widget and display the value using a text widget. Nothing new here. It looks something like this. But now we also need to implement the onPressed button so that it actually increments the value, right? So how can we do that? Well, we cannot watch the increment provider because we are inside of a onPressed handler. So if we wanted to do something like this, it's just impossible because we don't even have the watch parameter passed in because we are not inside of the consumer. So how can we instead read the increment provider just once and not watch it? So we can do something like context, read, pass in the increment provider, and then we can call increment. All right, now we press the floating action button and it increments just fine and everything works beautifully. Hopefully you can see the small text on YouTube too. Now let's briefly talk about the things that you can do with Riverpod that you just cannot do with the original quote-unquote provider. Because Riverpod's providers do not resolve just based on types. Even if you have two providers which provide the value of the same type, so in this case it's a string first and then a string second, you are going to be able to get both of the values perfectly fine. So if we have something like this stateless widget, turn it into a consumer widget, provide a scoped reader watch, and now we watch the first provider and also the second provider. We can do so from the same widget without any issues, and we're gonna be able to display both values inside of the UI without problems. So if we take a look now, we can see first and second displayed. Sort of, you cannot see it properly, but it's still there. Maybe if I enlarge the font size to 30, you're gonna be able to see it more properly. So we have first and second over here without any issues. Whereas with the traditional classic provider, so to say, we were not able to get both of the strings we could just get the string provided closer to the call site, if you remember from the beginning of this tutorial. Here, it's not an issue at all. Then another conclusion that sort of logically flows out of Riverpod not relying on types, but instead of variables, is that there is just absolutely no way that you can successfully compile a code which tries to get a value that is not existent. Why? Well, let's imagine that I try to get some provider which just doesn't exist from here. So my custom provider, right? This code does not even compile. It says undefined name, my custom provider. Why? Because my custom provider doesn't exist. But as you could have seen with the default provider, the traditional provider before, we were able to call provider int or provider of int like this, right? In a pseudocode without any issues, although still we didn't have any integer provider. This failed only at runtime, but with Riverpod, we're going to have an error on compile time. But let's get into something more real world, because all true apps have dependencies between classes. You just cannot make your way around that. For example, you can have a ChangeNotifier that depends on a repository, which in turn depends on an HTTP client. And even such nested dependency trees are a bliss to handle with Riverpod. To keep our example on the simple side, let's just have a FutureProvider depend directly on a simple fake HTTP client. The HTTP client is going to look like this. So it has just a single get method, which is passed a URL. And it's asynchronous and just delays for 1 second. And then it returns a string saying response from the passed in URL. We will need to provide this fake HTTP client using a provider, and since its value never changes, we can just use the classic, most simple provider, which you have already seen a few times already. Now, as I've said, we're going to create a FutureProvider to keep this simple. So let's create final response provider. It's equal to FutureProvider. And this is actually the first time that you see a FutureProvider, but I don't think that its creation requires much explanation, because aside from its name, it's pretty much like any sort of other provider. The only difference is that in its definition, the creation function is asynchronous, and that's about all the changes that there are to it, right? Now, because we have created a regular function body and not just an expression body, we get this lint warning or lint info message from here that we need to provide a type directly for the provider. So let's just say string, because the response is of type string anyway. And although you may be a bit confused by the term FutureProvider, it runs just like a regular provider. The creation function will run as soon as we try to obtain the value of the provider from the UI. So there is no like trigger method that you need to call in order for this future to run. It just runs as soon as this FutureProvider's create method is called. So how can we obtain our fake HTTP client from this FutureProvider? Well, we can use the ref, which is passed in, which is of type provider reference. And on this provider reference, we can call read. And we want to read fake HTTP client provider like this. And let's also put it inside a final HTTP client. You can also call watch, by the way, if you think that your provider's value will change, but in our case, we can just as well call read. And now that we have the HTTP client instance, we can return HTTP client.get, and let's just for now pass in a hard-coded string. So https://resocoder.com. And how do we use a value from a FutureProvider? Well, this is the most beautiful step in this whole tutorial, because using FutureProviders and also stream providers work in a very similar fashion. It's absolutely delightful. So the way that you can operate with a FutureProvider with Riverpod is that you classically create a consumer widget, and from it you can call watch response provider and put its value, or put this returned value inside the final response, and it's of type async value string. So let's actually call this response final variable response async value. Now this async value type comes from the Riverpod package, and it's a union. So this means that you don't need to use any sort of a clumsy future builder or stream builder for streams. You have a union which you can use in the way that you are used to if you have seen my domain-driven design tutorial series, or if you are a developer who uses freezed package, then you already know what I'm talking about. You have freezed unions inside of Riverpod. If you are not a freeze user, don't worry, because it's absolutely simple to use it. So we just want to return response async value.map, and we have 3 union cases which we can map to different widgets that are going to be returned from this builder function. So let's just do something like this, just so that we can format everything properly for you to see. And now whenever there is actual data inside of the response, we are going to display text and the value, which is of type string, inside of it. This is going to be the response gotten from the response async value. If we are just loading the data, so the future is currently in progress, we're going to display circular progress indicator. And in case of an error, we can display text error .toString. Error is going to be the error which has been caught coming from the response provider, if any such thing occurs. And then let's just style it to be a text style with a color of colors red. All right, so let's now take a look at that. We can see response from resocoder.com, and when we hot restart, go there, you can see the spinning circular progress indicator while we are waiting for the future to execute like this. All right. Currently, we are passing the same https resocoder.com URL to our HTTP client directly from the FutureProvider. But what if we wanted the user to pass in some sort of a custom URL directly from the UI, of course? Well, that's what provider families are for. The family modifier on a provider, which you can write like this, allows you to pass in a changing value, a non-constant value, so to say, just as you are invoking the provider's create function. You need to also specify the type of value which is going to be coming in. In this case, it's going to be also a string for the URL. And then the create function, in addition to the ref parameter, also holds the parameter which is coming in from the outside. So let's call it URL. And now we can use this URL string and pass it into the HTTP client's get function. And now, in order to pass this URL string to the response provider, we need to do it from the widget tree in this case, where now it's no longer enough to just say response provider like this, but we actually need to invoke it with some sort of a string being passed in. So let's just again say resocoder.com. And of course, we are again just passing in a hard-coded value, but since we are within the UI, it would be absolutely simple to have some sort of a user input, some text field, and use the values inputted over there and pass them to the response provider. I have now changed the layout of my screen so that you can see the emulator on the right side at all times. And whenever you change your provider to be a family, then you need to hard restart the app. And here we go. Response from resocoder.com. So now we can change the URL passed into, for example, youtube.com, and the future will be rerun. You can see the spinning progress indicator. Let's go to google.com. Again, the same thing happens. But now let's actually go back to resocoder.com, and no progress bar is over there. Let's go to YouTube again. And again, no progress bar. Google, no progress bar. But if we go to, I don't know, let's say flutter.com, although flutter.dev, I guess. Now we again see the circular progress indicator. So what's happening? Well, this is all because the state of our future response provider is not being disposed. And this can be also a good thing, but also a bad thing. The reason why we don't get any circular progress indicator if we go back to resocoder.com is because we have already requested this response provider with this sort of a URL passed in. And since we are still within the same stateless widget, which has not yet been disposed, the provider has state, which is still stored inside of the provider container up here in the provider scope. So this caching feature is amazing because it allows you to save on bandwidth, for example, because you are now going to request the same URL multiple times if you absolutely don't have to. But sometimes you actually may want to perform requests on the same URL over and over again. So therefore, we need to have a way to dispose the state of a provider. So therefore, we need to have a way to dispose the state of a provider whenever it's not being used or listened to using a watch, and not just when the widget from which it's being used gets disposed, right? And to dispose a provider whenever its value is not listened to, we can use the auto dispose modifier. Let's save that. Let's again restart because we have added a modifier. And now when I have resocoder.com, then go to youtube.com, we see the spinning indicator. But when I go back to resocoder, we are again going to see the circular progress indicator because the resocoder.com's FutureProvider state got automatically disposed. Now we are using the auto dispose modifier with the family modifier, but you don't need to necessarily use these two together. You can have auto dispose just by itself. And then again, whenever the provider would not be listened to, then it's gonna get automatically disposed. So you have just learned the essence of the Riverpod package, and we've gone through the very basics all the way to provider modifiers. And of course we can go more in depth because this package has a lot more to offer. So if you do not want to miss the upcoming tutorials about building more advanced apps with Riverpod, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. And to go through this tutorial at your own pace once again and to get all the code, check out the written tutorial available from the link in the video description. Lastly, if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education, link is also in the video description by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. If this video helped you with understanding the basics and also a bit more advanced concepts of Riverpod, give it a like and also share it with other developers who are surely going to find this Flutter content beneficial too. Leave a comment if you have anything to say, and see you in the next video.